everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about diode circuits as clippers. So, as a part of definition, clipper circuits are the circuits that clip off or remove a portion of an input signal without causing any distortion to the remaining part of the waveform. So, there are also called as clippers, clipping circuits, limiters and slicers. Clippers are basically wave shaping circuits that control the shape of the output waveform. So now we will discuss little more about clippers as a part of their applications. The applications of clipper. They are frequently used for the separation of synchronizing signals from the composite picture signal. Now what this term composite picture signal means here. Composite signals are signals which are made up of many signals like we do in video signal. We have one audio signal, one video signal and the color coding signal also. So this is the mix up. When mix up of signal is there, then these signals are composite signals. Now what happens when we use output as in composite signal, there are few signals which just synchronize with the system and which we don't need for the final output. So with the use of clipper, we can clip off them. The second application is the excessive noise spike above a certain level can be limited or clipped off in FM transmission by using the series clipper. Now what this means, we know that excessive noise can create distortion in the output. So in frequency modulated transmitters, what we do, we just clip off them with the use of series clippers. Now the third one is for the generation of new waveform or shaping the existing waveform, clippers are used. The typical application of a diode clipper is for the protection of transistor from transient. Now, what the term transient means here? Transient is a signal which is just generated, with the excessive current. So, it is a spike-like signal. So, we have to remove it. We can remove it from the use of clippers. Now, a frequently used half-wave rectifier in power supply kits is a typical example of clipper. It clip off either positive or the negative half cycle of the input. Now, clippers can be used as voltage limiters and amplitude selectors. Voltage limiters, it means they can limit the voltage. Why so? Because we are moduling our output voltage according to particular clipper, and they are also amplitude selector. Which amplitude I have to go for, they are like that only. Now we will discuss one by one the process of clipping, which is series positive clipper. Now what is happening here? The diode and the resistor, this diode and the resistor connected in series with each other, and we are clipping the positive half of the input. So this is the input cycle, 0 to plus volt. So in first, the polarity will be plus here, negative here. So what happened? Diode negative is here and diode positive is there. Now we can see that voltage battery positive terminal connected to the negative of the diode terminal. So the diode is reverse bias in first half. If the diode is in reverse bias condition, then it will behave as an open circuit. If it will behave as an open circuit, then the current in the resistor R will not flow. If the current in the resistor will not flow, what will have? We will not have any output at Vout. So the portion here is clip off for the positive half cycle. Now what is happening in the negative half? Let's see the structure again. In negative half, what is happening? In negative half, the polarity will be changed. Why so? Because we are considering this 0 to minus V. The polarity will be changed. Now, this is the polarity of the diode. Now, in this condition, we clearly see that negative terminal of the battery connected to negative terminal of the diode. So, diode is in forward bias condition. If diode is in forward bias condition, it means it will allow current toward this resistor. If it is allowing current toward this resistor and working as an conducting path, then this resistor we will get some current across this resistor and V equal to IR. So we will have some voltage across this resistor clearly. So this voltage is nothing but that one, which is negative half cycle. Okay, similarly it is happen for next positive and next half cycle, which is this. Now we will discuss the another one, which is series negative clipper. Now in this, the diode and resistor are connected in series and we are clipping the negative half of the input. Okay, the negative half of the input we are clipping. So here what is happening? In first half, positive negative, this we are considering. or this is the positive side of the diode, this is the negative of the diode. So in positive half, the diode working as forward bias because positive terminal connected to positive of battery. So diode is in forward bias condition. If diode is in forward bias condition, it will allow conduction, and at register, across the resistor we have some voltage here. So this is the voltage. And what happen in again when we reverse the polarity, or we will consider the case of negative half cycle, what will happen? The polarity will change. If the polarity will change, then what happened? Diode working as a blocking bias or a reverse bias because negative terminal connected to positive of the diode. So diode is in reverse bias condition. If diode working reverse bias, that means no current across this resistor and no voltage at the output. So this is the basic circuitry of series positive and series negative clippers. Now we will discuss parallel clippers. Let us discuss the case of positive parallel clipper. Now what is happening in parallel circuit? In parallel circuit, the resistor and diode are connected in the parallel system. Now what the parallel system means? A parallel system is simply current dividing system. Okay. Here we can see current is coming from this resistor R. Current is coming from this resistor R like in this manner, and it is dividing in diode place and dividing in the V out place. Okay. So this is the particular division node. So this system is in parallel connection. Okay. Now what will happen in positive half cycle? We know the polarity will be like this only. This is positive, this is negative, and this is diode's positive, this is diode's negative. What happened? Diode working in forward bias because positive connected to positive. If diode is working in forward bias, it means the current the current will flow in this direction. Now what will happen if current is flowing in this direction and not going into that direction? Okay, current is flowing in this direction and not going into that direction, so we are not getting anything at the output. Why so? Because the diode possess here very low resistance path. It means every current, whatever the current is coming from this node, is directly going towards this diode and not going towards this V out. Why so? Because diode is providing a very low resistance path. It means current will flow abruptly into the circuit. And if it is case of ideal diode, then we know that in forward bias, ideal diode work as a short circuit. So here all current is going towards the ground and we are getting nothing at the output. Okay, because according to current division, all current is flowing towards this diode and not coming toward this node. If current is not coming toward this node, it means whatever connected to the output, we are not getting in the final output. Okay. If input is Vi, all the current consumed by the diode, so we are not getting anything at the output. So at the output, the positive half is clipped off. Now for the second condition, what will happen? For the second condition, here the negative and the positive, and this is the diode positive, this is the diode negative. Diode is working in reverse bias. If diode is working in reverse bias, what is happening? Diode in reverse bias work as an open circuit. If something is in open circuit, it means no current will flow towards this diode. If no current is flowing towards this diode, it means whatever current is coming from this resistor is going towards the V out. So we have here the negative half of the input. Clearly? Similarly for again, this is clip off and this is we are getting. Now we discuss series clippers and parallel clippers, and we will discuss biased clipper and double biased or double diode clippers in our next class. Thank you so much.